This is a CCEA past paper question. It is from the C1 module and it was issued in May 2011. In this question, you have to find x. You're given 25 to the power of x minus 1 is equal to 5 root 5. Ideally, I would like a number to a power and another number to a power, whereby this here, base here, is the same as this base here. So then I'm able to say that this is the same as that. Looking at these figures, an obvious choice for a common base would be 5. So 25x to the minus 1. 25 is 5 squared, so I'll introduce the number 5. This is equal to 5 root 5. Now number 5 has the power 1 on it and is multiplied by 5, which is square rooted. The square root of 5 is equal to 5 to the power of a half. So I can put a half here. If two numbers have the same base and being multiplied together, you add their indexes. So it becomes 5 to the 3 over 2. Over here, you see that the index of 2 from the 5 squared is split by a bracket, and the other side is x minus 1. When two indexes are side by side and split by a bracket, the rule is that you multiply them. So 2 times x minus 1 is 2x minus 2. Now, I have what I was looking for. Two expressions. One, 5 to the 2x minus 2, and 1, 5 to the 3 over 2. They have the same base that I was hoping for. So I can now say that this is the same as that. So 2x minus 2 is, in fact, 3 over 2. If I add 2 to each side, then I will get 3 over 2 plus 2. So 2x is equal to 3 over 2 plus 4 over 2. Given them the same denominator, gives me 7 over 2 to be 3x. So, 2x. So that means that if I divide each side by 2, x will become 7 over 2 divided by 2, which is 7 over 2 times a half, which is 7 over 4. I remind you, the C1 is a module where a calculator cannot be used. And that is your answer. So 25 to the power of 7 over 4 minus 1 is the same as 5 root 5.
Part B of this question asks you to simplify as far as possible the fraction 2 plus root 5 over 3 minus root 5 added to the fraction 5 over 3 plus root 5.
When looking at this question, it is useful to remind yourself about ordinary simple fractions that you would have done in junior school. So if you had 1 over 2 add on 1 over 3, you would have made sure that the 2 and the 3 were changed into a common denominator, making it 3 over 6 add on 2 over 6, which you then got 5 over 6. The same concept is applied here. You need a common denominator before you can add these two fractions. The common denominator observed, straightforward, is the 2 times the 3. So I'm going to apply the same idea and give a common denominator of 3 minus root 5 times 3 plus root 5 to each of the fractions. Take care with your brackets when you're doing this. This fraction had to be multiplied by 3 plus root 5 in the bottom, so it will also be multiplied by 3 plus root 5 on the top. The same way that this fraction had to be multiplied by 3 to get 6, the 1 was also multiplied by 3 to get 3. Similarly, the 5. This fraction had to be multiplied by 3 minus root 5, so I'll multiply the top by 3 minus root 5. Now, at this stage, I'll just consider the denominator. The denominator is 3 minus root 5 times 3 plus root 5. If you apply FOIL to the multiplication of these two brackets, you'll soon find that 3 times 3 is 9. Root 5 times root 5 is 5. On closer inspection, you observe that it's minus root 5 times 5, so make sure you remember your minus sign. You then get 3 times minus root 5, which gives you minus 3 root 5s, and 3 times root 5, which gives you 3 root 5. Gathering this together is quite straightforward. 9 minus 5 is 4, minus 3 root 5 plus 3 root 5 just gives you 0. So the denominator is simply 4. The next stage is to write out your fraction. Both of the values have a common denominator of 4. FOIL will have to be applied to the numerator of this fraction. 2 times 3 is 6. Root 5 times root 5 is 5. 3 root 5 and 2 root 5. Adding on. 3 times 5 is 15 minus 5 root 5. This is over 4 and this is also over 4. Now, that's 11 plus 5 root 5. All over 4. And over here, I have 15 minus 5 root 5 all over 4. If I'm going to gather this all over as one fraction over 4, 11 plus 15 is 26. And 5 root 5 minus the 5 root 5 will give me 0. So I'm left with 26 over 4, or 6.5.
The next part of this question is a transformation of a graph. Y equals f of x is given to you. This line goes through the y-axis at 3 and the point A, which is minus 2, 1. You're asked to draw the graph of y equals minus f of x.
This is the function that you have been given, and you're told that A has the point minus 2, 1. You're asked to draw y equals minus f of x. If y is equal to f of x, all the answers for f of x is the y answer. So if you get your y coordinates after having taken the fx answers and multiplying by minus 1, when A is the point minus 2, 1, the y number will become minus 1 for the new point A, for the function y equals minus f of x. Likewise, if you had the point 0, 3, the y value, which is f of x, is now going to be multiplied by minus 1, which gives me 0, minus 3. The x values have remained unchanged, but the y values are now their negative. In fact, the process of changing y equal f of x to y equals minus f of x is the transformation called a reflection. And the reflection is on the x-axis. The new graph, the new function, is very similar and simple to draw. So what was minus 2, 1 is now going to be -2, -1. And that point is A dash. What was 0, 3 is now going to be 0, -3. And the behaviour of the rest of the graph will be the same. So we then know that we have a similar shape of graph, simply reflected off the y-axis or the x-axis.